Hello viewers, welcome to my channel. I am Dr. Leela with a series of lectures on signals and systems and Python. Today I am going to explain how to use Python for testing the signals for their even and oddness. That is, to find out the even and odd components of the signal and whether the signal is an even signal or an odd signal. So to do this, I am taking some examples, 4 examples. 2 are from continuous time and 2 are from the discrete time domain. This already I have explained how to manually find out the even and odd components of the signal in my series on signals lecture. So let me take you to the Jupyter notebook. Here I have listed all the 4 problems that I am going to solve using Python. So I'm importing Sympy. I will be using the Python module Sympy for solving these problems. I have already explained in my series of lectures on Sympy part 1 and 2 how we can make use of, how to use the Sympy and what are its capabilities, some of the capabilities that we will be using in understanding the signals and systems problems. So import Sympy as short form SP, and from Sympy import all the functions. And let us see what are the symbols that we are going to use in these 4 problems. So first of all, T is one of the symbol, and next small letter A, and then N, and then omega. These are the 4 symbols that we will be using. So define them as symbols. So T, comma, A, comma, N, comma, omega. So the Greek letter omega, in order to pretty print it, you give it as omega, omega, and define them as symbols, and within parenthesis and quote list all those we want to define the symbols. And also initialize the pretty printing with the init printing, make the pretty printing is equal to true. So let me run this cell. You observe the star here while it is being running, and once that is over, it will, number will appear here. So this is a heading line where first problem I am taking except t is equal to 3 cos of t by 2 plus 5 sin of t by 3. I am representing the given signal as x1, which is 3 times cos. Since cosine I am calling from the Sympy module, I am attaching sp as preceding this cos, sp dot cos of t by 2 plus 5 into that is star sp dot sine of t by 3. This is the given signal, and replacing t by minus t, that signal I represent it as a variable x2, which is 3 into sp dot cos of minus t by 2 plus 5 into sp dot sine of minus t by 3. So this is my original signal x of t, and this is x of minus t. So let me get the display of these two signals, x of t and x of minus t. So the function command here display will display the x1, which is the given signal, and it designates it as x of t. So within parentheses, whatever I write here, it will be taken as a string. So x of t is equal to, then whatever x1 on the right of this x1 variable, that will be printed. So our x of t is equal to 5 sin of t by 3 plus 3 cos of t by 2. And then the next line display x of minus t, which is x2, that it has displayed as x of minus t is equal to, after replacing t by minus t, we get minus 5 sin of t by 3 plus 3 cos of t by 3. So Sympy has simplified this with t taking negative. Now we know that the even component of the signal is given by x of t plus x of minus t whole divided by 2. So x of t is our variable x1, x of minus t is our variable x2. So add the 2 and divide by 2, and then print it as uh, uh, even component, and get the value of xe. So let me run this cell. So our even component is 3 cos of t by 2, which is evident from the given signal. and the odd component is subtract and divide by 2, which is 5 sin of t by 3. Okay, so from inspection of the given problem itself, we can state here that this is the even component and this is the odd component. Okay, take the next problem, which is x of t is equal to a sin of t whole cube. So define x of t with a variable x3, which is a into sp dot sin t whole cube, and negative of that is x4, which is a into sp dot sin of minus t whole cube. So let me display the x of t and x of minus t. So x of t is a cube sin cube of t, and x of minus t is minus a cube sin cube of t. So what is the even component of the signal? xe is equal to x3 plus x4 divided by 2, and I am asking it to display the even component as xe. So we know that this doesn't have an even component, it is purely odd, so its even component is 0. So let us see what we get for the odd component. So the odd component is a cube sin cube of t, which is the given signal. So let us take the next problem. X of n is equal to sin n omega plus 1 whole square. So I am taking this, since this is a whole square, let me expand this. Expand sp dot sin of n into omega plus 1 whole square, and then display the x1. So that is equal to sin square n omega plus 2 sin n omega plus 1. And similarly, this is x of t, replace x of n by minus n and expand it. I am calling it by a variable name y1. So this is the expanded version of replacing n by minus n in the original problem. Okay, so the even component is sum of the 2 divided by 2, which is sin square n omega plus 1, and difference of the 2 divided by 2 will give us the odd component, is 2 sin of n omega. So take the next problem, which is cos n omega plus 1 whole square. So, and replacing n by minus n, original signal I am representing by the variable name x2, and replacing n by minus n I am representing it as a variable name y2. So let me run this cell. So after expanding, cos n omega plus 1 whole square is this, and after expanding cos of minus n omega plus 1 whole square, we get same as the previous one. So even component, that is the whole of the given signal itself is the even component. I must get this odd component as 0 as expected. Okay. So that is about the 4 problems that we have solved using Sympy. That's all for today. Thank you for watching. If you like it, like, share and subscribe and give your feedback. See you in my next lecture.